Hi, this is Mrs. Basin, and today we're going to talk about the chemical mole and molar mass. So the first thing we're going to look at is the concept of the mole. So the mole is a unit in chemistry that we use to represent 6.02 times 10 to the 23rd units of a substance. We sometimes refer to it as the chemist's dozen. So when you hear the word dozen, you associate it with 12. So now when you hear the word mole, we're going to associate it with 6.02 times 10 to the 23rd. This value is defined as being equal to the number of atoms in exactly 12 grams of pure carbon-12. So that's where that number comes from. It's used to describe numbers of atoms or molecules, and it allows those numbers to be a little more manageable because atoms and molecules are so small. It also establishes a relationship between mass and numbers of atoms, which then allows us to count atoms by weighing them. So one of the conversions we're going to use is 6.02 times 10 to the 23rd atoms or molecules is equal to 1 mole. The value of this 6.02 times 10 to the 23rd, is known as Avogadro's number. So this is named after Amadeo Avogadro, who lived between 1776 and 1856. So 1 mole of anything is equal to 6.02 times 10 to the 23rd units of that thing. So it's a ridiculous number to use if you're talking about larger objects, because that's a ridiculous number. It's something that we wouldn't even be able to count. But when we're talking about atoms and molecules, which are very small, it is a number that we're able to use. The next thing we're going to look at is molar mass. So the average mass of the molecules or formula units that are in a compound is called the formula mass. The formula mass is the sum of all the atomic masses of all the atoms in its chemical formula. So to get the formula mass, you take the numbers of atoms the numbers of atoms of the first element in the chemical formula times the atomic mass of the first element, plus the numbers of atoms of the second element times the atomic mass, and then you continue on for however many elements there are in that formula. The atomic mass comes from the periodic table, so it's that mass value from the periodic table that we've talked about before. The formula mass is important because it's equal to the molar mass. So the molar mass of a compound is equal to 1 mole of that compound. So molar mass can be used as a conversion factor when we're trying to figure out the mass of atoms or molecules present. So the units for molar mass are going to be grams per mole or G/mol. So now we can say 6.02 times 10 to the 23rd atoms or molecules is equal to 1 mole, which is equal to molar mass. And in the next set of notes, we're going to learn how to actually use that as a conversion factor. So for today, what we're going to do is do a couple example problems. So the first one we're going to look at is, what is the molar mass of sulfur dioxide, which is a gas produced when sulfur-containing fuels are burned. So this is how we're going to pull in the information from the last chapter. So we know sulfur dioxide is SO2. So the easiest way to set these up is to make a list of the elements present in the formula. And then I'm going to look at how many of each are present. So there's 1 S and 2 O's. Then I'm going to multiply that by the mass of those individual elements. So that number is coming off the periodic table. When we take that number off the periodic table, we're going to round to 2 decimal places. So sulfur is 32.07. So that gives me 32.07. Oxygen, 16.00. So that gives me 32. And then I'm going to add those values up. And again, we said that's grams per mole. So that is the molar mass of sulfur dioxide. So for the next one, we're looking at something called polyvinyl chloride, or PVC, and this is used for floor coverings. You've probably heard of PVC pipes. It's made from a molecule with the formula that's given. So if it's something that you would not be able to come up with a formula for based on what we did in the last unit, then I would give you that formula. So we're going to calculate the molar mass of this compound. So I'm going to do the same thing here, where I'm going to list the elements, list how many of each, so that number comes from the formula. I'm going to multiply by their individual masses, and these numbers come from the periodic table. So 24.02, 3.03, 35.45. So my total here is 62.5 0.0 grams per mole. So that's my molar mass of PVC. Great, last example. Maybe stop, try this one on your own, and then come back and check. So calcium hydroxide, I know how to write the formula for this. So CaOH2. So I'm going to do the same thing here. CaO and H. So there's one Ca, and then if you remember from the last unit, we talked about how that 2 goes to everything inside the parentheses. So there's 2 O's and 2 H's. So calcium's mass is 40.08, 16 for oxygen, 1.01. So 74.10 grams per mole is my molar mass for calcium hydroxide.